It's basically done. It just needs 2 more weeks of finishing touches. Those words were a red flag. The previous developer had to leave suddenly, and I inherited what looked like a working shipping system. But when I dug deeper, I discovered the programmer was trying to force a system designed to print one manifest for all packages to somehow generate individual pallet manifests for each shipping station, using the same built-in manifest function. It was never going to work. What should have been a simple handoff turned into a complete rewrite. And that's when I realized something critical. The developer wasn't necessarily a bad programmer. He just didn't have a system for thinking through the problem before he started coding. If you've ever felt overwhelmed by programming tutorials or class, or tried to build something only to watch it fall apart, or worked with AI coding tools that seemed to understand you at first, but then went completely off the rails, the problem isn't your coding skills. The problem is that nobody taught you how to think like a programmer before you start typing. Have you watched programming videos and felt like you knew it only to find yourself confused when you started coding? Have you done some coding but want to get better? Have you written code only to find it riddled with bugs you can't trace? Have you tried to code with AI and watched your project go completely south? Most people struggle with coding because they are never taught programming. Here's the distinction. Coding is a language-specific commands that are used to cause the computer to do something. Programming is a process of breaking down a problem or a goal so that the software program is in small, simple parts that can then be coded using a programming language. So oftentimes, because these two both end up developing code at the end, they call them coding or they call them programming, or the words are used interchangeably, but they're actually very different concepts. So what normally happens is people are taught coding and they're supposed to somehow magically generalize that into programming. And that normally doesn't happen. So today I'd like to sit down and talk to you about programming and show you how that works so that you can then take that and go back to your coding and say, okay, I know this is what I want to do. How do I do that? The coding programming solution. 47 years ago, at my first computer job, right out of high school, I was blessed to be mentored by a mini computer programmer who taught me a specific system, a system of programming that drastically reduces the number of bugs in your code, and when a bug does appear, you immediately know where it is. But the system did something else too. It allowed me to code complex projects faster than the people who code first and try to figure it out later people. And the system worked regardless of the computer language I used. So today, there are thousands of languages that you could use. If you look at the ones that are commercially in use, there's over 100. So how do you learn 100 different languages? And the right answer is you don't. If you look at their purpose, it's to simplify the writing of actual numbers that the computer processor uses to do things. The goal of a language is to provide a more human way to describe a task, which makes programming by humans easier. Many of these languages are very, very similar and share things. So for instance, C. If you know C, you probably know C++, C#, Python, PHP, Java, JavaScript, Go, and Dart. All these languages use roughly the same syntax. The key feature that you'll notice for C languages is they all use, whenever you have to check if something is equal to something else, if A equals B, it has to be A equals B, double equals. If it's a single equals, it assigns it that value and then sets it to true. All C languages work that way. And there are other groups of languages that work other ways that are, again, all pretty much the same, like all basics, have very similar syntax. And once you know one, you can translate that into the others. But the reality is that this system of group flow prove works across all languages. It's actually language agnostic. So now that you're aware that there are different languages and languages aren't as different as everybody claims they are, it's more syntax and grammar, specific words that they like to call things in this language that they call it something else in this other language. But let's talk about group flow prove and break that down a little bit. So when we're talking about group, every group, which is something you want to accomplish, is broken down of subparts, which are groups in and of themselves. And those groups also have a flow, they also have a prove. So the group part, there are two types of groups. There are only two types of groups. One is data groups. So these are going to be the tables or files that you're bringing information in from, or the data you're trying to get from someone's screen for them to enter in. So you've got data groups, and then you have functionality groups. There's groups that are, on one hand, you could think of them as creating functions, but they don't necessarily always create functions. It's the functionality that this group needs to have. In other words, these are the steps that this group goes through to accomplish its task, whatever that is. So you have the group, you have the things it needs to do, the functionality it needs to have, and then that functionality gets put into a flow. So every group will have a flow. This is the first thing, this is the second thing, this is the third thing. Well, what if it does multiple things or can do multiple things? Well, then you create something like a flow chart where you have one point in, and depending on what it is, it takes different paths through. And so a single group can have multiple flows. And those flows can each have one or more steps. But the key thing about flows is this is what we often talk about in programming, and this is why a lot of people get confused, is input and output and processing in between. So every flow has an input, it has some processing, some steps that it does, which is typically your groups, and then it has an output. What do you get out of this? Does it update a file? Does it turn a switch on? Does it return a value? What is the output of it? And some things don't have outputs. They just terminate the program or they terminate the process, and there is no actual output as such. The prove step, this is where you deal with the bugs. And instead of dealing with the bugs at the end and trying to write all this code and then say, well, how should I test it? What we do is we move it up to the group. So every group needs to be tested. Each sub-functional group will be broken down to other groups, and they'll need to be tested. And so what you end up with is a system of testing all the way up through. So the question here is, how can I prove that this group or function that I'm writing works? And that's very important. It's different from saying, well, how do we test it? This is how do you prove that it works? And your testing has to prove that this is actually doing what it's supposed to do. And that's a very important part, very important element of this whole thing. So when you start that from the lowest level, from any function that you create, how do you prove that it does what it was supposed to do? How do you prove that? And once you may have to write a little test program or something to prove that. And then once you prove that, then when that's used in the next level up group, how do we prove that that next level up group does all the things that it's supposed to do and is generating the results it's supposed to? And so this way, we get into testing, we get into dealing with bugs way ahead of the game rather than writing a bunch of code and then later seeing if what we wrote works. And then the secret sauce to this, the fourth element that I haven't talked about because it gets smeared in all of this, is simplify. How can I combine things? how can I make this whole process simpler? So on the group side, are there groups that are doing the same things? Like a lot of times people will create an application. You'll have like a create item screen, a list item screen. You'll have a view screen. I shouldn't say list item, but edit. Normally it's create item, edit item, view item, and delete item. Well, there's 4 different screens that you could have written, right? But Simplify says, how can we do this with fewer pieces? Because when you write 4 different screens and you add a field to one screen, now you've got to add it 4 times in 4 different screens. And you create a lot more work for yourself, where if we combine those 4 screens into one screen and we start looking at what is the functionality difference, what's the difference in those subgroups of how this screen is supposed to work and flow. Now, how can we incorporate those together? What do they have in common? What do they have that's different? And now we put it all into one screen with some control logic that makes it operate in different ways. Now we add a field and we have to modify just one screen now. But the beauty of it is then all this other functionality that is custom to how that screen works and what turns on and what fields are not available for input, that type of thing. All of that can be dealt with right at that one time. And it's all part of the testing for that feature being added. It's part of your proof for that screen now, or that screen change. So you want to simplify as you go through. How can I make this flow? Do I really need this many flows? Is there another way to look at the flow through here? Or are there additional flows? Or a lot of times I'll get in and I'll work on a flow and I'll realize I need another function. I need some additional functionality because what I'm doing here doesn't make sense, or there's a gap and I'll see it in the flow. Now I can go back to the group, add a group. Now, how do I simplify this? And then on the proof side, a lot of times it's easy to write a list of proofs. Okay, we're going to do all this testing. And the reality is a lot of those tests are redundant, or they have pieces that are redundant. So maybe I can take one test, build one test, and do 3 or 4 different tests all as part of this one test. And I can test multiple features of this particular thing by just doing this single test. So how do I combine things? How do I make them simpler? Because we don't need endless lists. What we need is short, concise lists with the key things that we need. So let's look at a real world example, okay? Hello world. Favorite thing for everybody to do in a computer programming language. So if we look at this from the group flow proof, we might have a data group that would be a variable that's going to hold hello world. And then we would have some sort of functionality that is going to make that hello world variable visible to the user. And so we're going to have some kind of command that's going to show that to them somewhere. And that's it. That's all we need for hello world. Okay, so we're going to have a variable that we're going to input, and then we're going to take that message that we loaded, hello world, and we're going to then send it to an output. And how we prove it worked is we see the hello world on the computer screen. Now, if I apply simplify to that, how could I simplify that? Do I really have to apply hello world or store hello world in a variable? No, I don't. So I could actually put hello world into the display function or print function that displays the text. So I can just send the text to the function that does the displaying of hello world, and I'm done. And now we've taken something that's rather complex and we've simplified it. Okay, so let's build a contact app as a sample of how this process works. So level 1, the highest level is going to be the app. And then under the app, we're going to have groups, we're going to have a flow, and we're going to have a proof. So our groups are going to be high-level things. So it's going to be like the data that we want to store. So things like the name, the phone number, the email address. In fact, why don't you stop right now and make your own list of what you would put in a contact app? What information do you think needs to be stored? So go ahead and pause the video here, and then I'll wait until you get back, and then we'll continue on. Welcome back. So the next thing is, what is the functionality? So on the contact app on level 1, on the highest level, we're talking about what screens do we need. So we're going to need a create contact screen. We're going to need a list contacts screen. We're going to need a screen that shows us all the contacts that we have in the app. And we're going to need a display contact information screen. And we might need a change contact information screen as an additional screen. So that's the functionality at level 1. What's the flow? The flow of level 1 is going to be, you're going to create a contact, because if we don't have contacts, we can't list any contacts. We're going to display contacts in a list of contacts. We're going to display individual contacts information. So we're going to have some way that we select a contact on that list of contacts and we display their information. Now, how do we prove this? Well, what we need to prove is that we can create a contact, they show up in the list, and then we can view them. That's how we prove that the app works at this level, with this level of sophistication and the requirements we have right now. In reality, you would have a lot more requirements, a lot more things, but I'm trying to keep this short and simple. So the next step is, how do we simplify? How can we refine what we're doing here? So we know that we can prove that we got a contact because we see it in the list, because we display it. But how can we simplify the process? So, for instance, I said, what are the variables you would store? So for me, I would take name, even though that was like, okay, starting point. But normally you have person's first name and last name, because if you want to use it later for an email or something else, you're going to want first and last name. What about company? In your list of things that you created, did anyone select company as a field that maybe we should have added? Or what about notes? Should we have some kind of notes about this client so we can remember who they are, where we met them, what's notable about them, whatever it might be? And then how do we uniquely identify our contacts is something we didn't even talk about, is a unique ID. Is that when we put these in a database, normally if you want to find something, you want it to have some sort of unique identifier. So you're going to need a unique ID. And then for functionality, we've got to create and display screens. Maybe we can combine those two into a single screen and just have it come in one mode, it does create. In the next mode, it gets, I don't know, maybe a unique ID gets sent in, and that tells it that, oh, it's time to display. And so we're going to display the information about the person instead of giving you the ability to create it. And if you want to edit it, maybe we can have it so it has it as an edit, as a default. And then the question is, do we need a delete contacts? Probably. So what's the flow then for this? So we're going to create a contact. We're going to be able to list it. We're going to be able to edit it. If we edit it, we're going to need to save it. If we create a contact, we can list a contact and we can view a contact. And those are the two flows that you're going to have there on level 1. So whether you're a coding programmer or a no-code programmer, this piece is pretty much the same, and you actually go through these same steps. And this is the important key things that you need in order to build that application. So if we move now to level 2 and we start breaking down level 2 would be taking like just the create contact screen. And I'm going to leave it as create contact just for simplicity right now. But take that screen, and now we're going to make that the group, the main group, and it's going to now have subgroups. So it's going to have a data group. And like I said, I'm going to break the name into first name and last name. So I'm going to have first name, I'm going to have last name as a string, I'm going to have phone number as a string, I'm going to have email as a string, and then I'm going to have a unique ID that could be a string or an integer variable. And then function groups. I'm going to need a function that loads the contact entry screen, right? We're going to need some functionality around entering data. And then we're going to need a save button and a cancel button on that create screen. And that's pretty much it. That's the basic, very most basic groups that you could do. Depending on the language you're implementing this in, you may have something more complex. So what's the flow now of the group? I'm going to generate a unique ID is the first thing. When I open it up, I'm going to add a first name, I'm going to add a last name, a phone, an email, and then I'm going to either save or cancel the creation of this new contact. How do I prove this? Right? Because I said prove. How do you prove the create screen? A unique ID is generated. It's displayed on the screen. The screen appears with all fields where the programmer wants them. The screen allows the user to move between fields easily. Then save is pressed. A contact record is saved in the database. We check the database to see if a record was put in there. And then when cancel is pressed, we make sure that no contact record was saved and the user returns to the main menu. Those are the things we need to prove at level 2. Now notice that level 1 and level 2 are actually, not only are they coding, and there's no code at this point yet, but for no-code programmers, this is the core of what you're doing. This is the core of what you're really trying to work with and trying to develop. So the process of group flow proofs continues on for every part of the application. So it continues on for the other fields, the other screens that you're going to have if you have other screens. And then what's the practical application? The practical application is this systematic approach of group flow proof is not just old school programming. It's essential for modern programming languages, including AI coding and no-code, low-code platforms. For no-code, low-code programmers, typically level 1 and level 2, like I said, breaking down what you need is enough. And you're defining these high-level groups and the flow between them. If you need to do some low-code programming, then you're probably moving into level 3 or level 4 type breakdowns, where I need specific functionality associated with this screen. And how do I do that? For AI coders, what you're finding is that the AI can't just go off and make it up, because once you start using this group flow proof method, you'll realize how complex even the simplest of applications is. And AI really needs very clear directions of exactly how do you want this to work? What functionality do you need and where do you need it? And so this whole system allows you to give the AI a good description and actually work through a project step by step, rather than giving it a project like build me a contact app. And you're hoping that it guesses like you would have wanted, or it somehow works like you want it to work. And then we evaluate the AI, whether it's doing a good job or bad job of coding based on that. That's just, it becomes ridiculous after you sit down and start applying this to what do you want. You start being able to give the AI very clear, definite directions. So I hope this has been helpful. I hope this has cleared up some confusion you may have had about how to start programming a project. The problem isn't your coding ability, it's the lack of system for thinking. By adopting group flow proof, you can approach any programming challenge, whether it's an app, a website, an AI prompt, with clarity, reduce bugs, and write code faster. If you would like a more in-depth explanation of anything I've covered or things you want to see a detailed breakdown for, please let me know in the comments. Thank you for watching. Please press the like and subscribe buttons to be notified of my next video, where we'll dive into simplifying variable types. So if variables have been something that's caused you some confusion or frustration, we're going to give you a little different way to look at those, and maybe that will help you out.